It's time for the Pythagorean Theorem. Are you excited? Because I'm excited. Okay, you've learned this before. We've kind of done this throughout the year, but like it's the day. Like today's the day we're doing Pythagorean Theorem. So let's get started. All right, the Pythagorean Theorem is a squared plus b squared equals c squared. But this only works for right triangles, and then a and b are the two shorter sides, and c is the hypotenuse. I've been calling this the hypotenuse all year because the hippo sits on the longest side. You know what? I can use these stickers too. It's Pythagorean Theorem Day, y'all. I'm excited. So here's my hippo day. All right. Again, only for right triangles. What if it's not a right triangle, you ask? What a great question. All right, well, if the two sides squared added up is bigger than the hypotenuse, then it's acute, and it's the opposite, it's obtuse. All right, our most common use for this, the one you're going to use the most often, is when I have two sides of a right triangle, and I'm looking for the third side. It could be any side. In this case, the longest side is always C. The other two can be A and B in any order. Fixed it. So it doesn't matter. So we'll just say A and B, but these could be switched. Does not matter. The only thing that really matters is that C is the longest side. So in this case, I'm going to fill these in. So we know that the equation is A squared plus B squared equals C squared. I'm going to fill in what I know. So 5 squared plus 12 squared is going to equal x squared, because x is C. That's what I'm trying to find is x. Okay, so this is 25 plus 144. This is a great time to know your perfect squares, by the way. Okay, then 125 plus 144 is 169, which if I take the square root of that is 13, because 13 times 13 equals 169. So the hypotenuse is 13. Cool. There are some things called Pythagorean triples, which are actually pretty neat. The most common ones are 3, 4, 5. So if you see 3 and 4, this is automatically 5 and vice versa. 5, 12, 13 is a common Pythagorean triple. I'm cheating. I'm looking at my screen over here. 8, 15, and 17 is a common one. And then the one that blows my mind is 7, 24, 25. So if this is 7 and 24, the longest one's one more than that middle side, 25. It's weird. Okay, but some people get confused when x isn't the longest side, so I'm going to show you one example of that too. All right, so once again, I have the longest side. By the way, if you can't quite tell what the longest side is, it's always across from the 90-degree angle. So this is C, and then I doesn't matter again, so this is just A and B, let's say. All right, so I know, again, that A squared plus B squared equals C squared, so I'm going to skip the step of writing it and just start with the information. 7 squared plus x squared equals 14 squared. Okay, well, 7 squared is 49. And then 14 squared is a number. 196, obviously. I didn't know that. Okay, so then I subtract 49 over here because I want x to be alone. So I have x squared equals 147. Now I know, because I'm a math teacher, that's not a nice square number. So let's talk about how to find this. Because I'm going to do the square root. This is something that maybe Algebra 2 taught you, or Algebra 1 taught you. So to undo a squared, we do a square root. That's the opposite. Okay, that cancels that. And we've kind of done this for with distance formula, but I don't know, it's the same. Okay, so x equals whatever the square root of 147 is. Okay, if you have a yellow calculator and you do square root of 147, that's the green button and then the power 2. You get 7 root 3, which is a perfectly logical explanation for this, okay? That's the one I would prefer, but we're in a pandemic. You don't have access to these all the time. So if you use your phone, I should be pausing while I'm grabbing these things. I'm so sorry. Okay, this is on an Android. So we turn the calculator around, and then we do square root 147. Is that what I said? Yeah. It'll give me a decimal. That's fine. It's not ideal, but it is fine. So this is 12.12. I would take that answer as well. If you're on an iPhone, you have to do the number first and then the square root button. So you would do 147 and then press the square root button. It would tell you the answer. I don't know why. I don't know why they don't talk to each other. It's rude. Okay, so that's finding that number. So this is okay. This is preferred if you can. There's options online, but I don't want to stress you out too much. I just want you to know that it's the square root of 147, which is either 12.12 or 7 root 3. These are not, this is not a Pythagorean triple. 7, 7 root 3, and 14 are not nice. That's okay. That happens. We don't have to be rude to them. So I messed up a little bit. So I said determine if the triangle below is acute, obtuse, or right, but I realized that they're not going to show it to you because then you'll just visually look at it and go, oh, okay. But I do want to point out that to make a triangle, how do I show this? To make a triangle, I have to have enough length here to actually make this work, right? So if so the every two sides has to add up to be more than the third side to make a triangle happen. So for instance, and this is a really silly example because you would never see this, but these two caps are way smaller than this pencil or this pen. And so like this wouldn't make a triangle because they'll never be able to touch. They're just like, I can't. Okay, so it has to be, oh no, oh no, oh no, it has to be longer. So sometimes I'll ask you, normally I'd ask you if this is even a triangle, but we can tell. So 4.5 and 5.2 is bigger than 6.1, so we're good. Okay, so what do we know? We know that the length C is the longest, and then I don't care what the other two are. This could be A and B. Now, I told you above that if a squared plus b squared is more than c squared, it's acute, and if a squared plus b squared is less than c squared, it's obtuse. So let's just see which one it is, and if it's equal, they're right. So what we're going to do is we're going to take the a squared b squared, so we're going to do 4.5 squared plus 5.2 squared, and we're just going to see which one that is compared with a 6.1 squared. Sorry. I know math. All right, so let's do the calculator. Say, hey, calculator, 4.5 squared plus 5.2 squared is 47.29, and then 6.1 squared is 37.21. So the a squared plus b squared is more than the other side. So this is an acute triangle. Because it's the a squared plus b squared is bigger than the c squared. Okay. Okay, and then you're done with that, but I just wanted to show you, if you're a visual learner, stick around for just a little bit longer. Okay, so this is a visual representation of a squared plus b squared equals c squared, because here's my little right triangle. I make a whole square out of the a side and a whole square out of the b side, okay? And then this is the whole square out of the longest side, the hypotenuse, the c squared side, okay? So literally it's a square. It's a squared because it's a square with a as the side lengths. So this is one representation of how the area down here is equal to the area up there. All right, and then here's another one. So they have the same squares, but then it's a water instead. So it's draining out. It flips around, it drains again. So that same area for c squared is equal to both of those. All right, and then here's one last one. It's only showing half of it for some reason, but see how the full A kind of turns into a parallelogram and then turns into a rectangle. So it goes square, parallelogram, rectangle. The B one, the purplish one, also does the same thing. I just don't know why it's not. It's fine though, but that's the same thing. Okay, so it's literally the area of these two boxes can fill up the area of the third box. That's what the Pythagorean theorem is. Don't know if that helped you. If not, it's okay, just do the math. All right, and I'll see you in the next one.